we have a function which is the modulus of a function, and what we have to do is solve that function. So absolute value of x minus 2 minus 3 is equals to 1. So fx equals to 1, and we just put the value of fx. Now one thing about solving absolute value is we can solve it by taking first the negative and then the positive. So this is the concept of absolute values. So when you have modulus sign, modulus of function, and you have to solve it, what you have to do is you have to remember, if something is like this, absolute value of x is equals to a, it means x is equals to a and x is equals to minus a. We have to consider two separate situations. So what the absolute value does, actually it removes the negative sign. So if you write absolute value of minus 3, it will be 3, and absolute value of 3 is also 3. So the absolute value symbol, the two bar signs, actually removes the negative signs. And when we have to solve an absolute value equation, what we do, we send everything to the other side and keep the absolute value in one side, and then we take two separate situations. What if the whole thing was positive and the whole thing was negative? So what we can do here is, first of all we can send the 3 to the other side and write 4 here. So for, we can write x minus 2 equals to 4, therefore x equals to 6. And the next thing that we can do, for x minus 2 equals to minus 4, and this would be x equals to minus 2. So when we solve this, the answer is going to be x equals to 6 or x equals to minus 2. Now it is very important to notice if there is a condition for here. Now they said solve the equation. Now we have to recheck to see whether it holds true. Now in order for this to hold true, we have to plug in the value and see whether it works. If I put 6 here, 6 minus 2 is 4, absolute value of 4 is equals to 4, it works. If I put minus 2 here, minus 2 is minus 4, absolute value of minus 4 is 4. So this is correct. We can move on to the next one. Now in the exam, I recommend that you do the sum one after the another vertically, but here for space I'm doing it here sidewise. I do not recommend that you do it like this in the exam. So the next one, we have another function. It's a quadratic function, and we have to find the range. Now a note about range: when we talk about a function and we are talking about the domain, it is the input value. So that's the domain. What value is the input value, for which we have an output value? That's the domain. Any input value that gives an output value is the domain, and the output value is called the range. So when we're talking about the range of a function, we are talking about what output value is possible. Now for that, we have to think about the range of a quadratic function. There is a special rule for the range of a quadratic function. Now for a quadratic function, the range is actually, if the highest value is the maximum value, so fx has to be less than or equal to the maximum value, that is the y coordinate of the turning point. And if the y coordinate, if it is a minimum value, then it would be fx is greater than or equals to the minimum value. So whenever we are talking about range, we are actually talking about what is the value that is possible. Now here, if you take a look at the picture, so if a picture is like that, so this is the maximum value. Maximum value is usually the y coordinate. If a turning point has x coordinate and a y coordinate, the x coordinate is called the line of symmetry and the y coordinate is called the maximum. In this case the turning point is maximum, so I'm calling it maximum value. Here it would be minimum, so it is minimum value here. So when we talk about maximum value, minimum value, we are talking about the range of a function, because the function, this fx, this entire picture y equals to fx, this cannot go higher than this maximum value. So the function, we know what the value is going to be. It is going to be this one or less than this one. So this is very, very important that you remember that. So getting back here, for solving this particular sum, what we need to do is we need to know what is the maximum value, what is the turning point. So let's express gx as a complete square as we do in C1. So when we do this, a square minus 2ab plus b square, b is now 2 square, so I just cancel this off, minus 2 square plus 11. So this is going to be a minus b whole square, so a minus b whole squared, so we have minus 2 square is minus 4 plus 11, so this is going to be x minus 2 whole squared plus 7. So from here we can know that the turning point is 2, 7. So this is the rule from C1. Let me do a little bit of a C1 review here. A little bit of C1 review. So in C1, so what we do is that when we have any expression written like this, p x minus q whole square plus r, so what we do, the turning point is going to be, the y coordinate of the turning point is going to be the same whatever is outside the whole square, the complete square, added or subtracted, but the x coordinate of the turning point is going to be different. If this is x minus q whole squared, if it is minus q, this would be plus q, so it will be different, the opposite sign, but the y coordinate will be same. So here we know the y coordinate for this particular sum is going to be 7 and the x coordinate is going to be 2. So if you want to see what does it look like, so it will look like something like this. So it will, turning point would be x is 2 and y is 7, and it will be, since it is plus x square, it will be smile, a minimum turning point, so it will be like this, y is 7, 2, 7. So it doesn't cut the x-axis, so this is what the turning point is going to be. So now when they are talking about the range, you remember the rule, it has to be fx is greater than or equal to the minimum point, the minimum value. So here the minimum value is 7, the y coordinate is called the minimum value, so the sum is going to be range gx, because the function is called gx here, is greater than or equals to 7. So that's the range in this particular sum. Now for question number C, we have to find gf minus 1. Let me do here number C. So gf minus 1. Now before gf minus 1, it means we have to put f minus 1 inside of g. So in order to do that, what we need to know, we need to find the value of f minus 1. So this is absolute value of x minus 2 minus 3. So for f minus 1 equals to absolute value of x minus 2, x is minus 1, minus 2, minus 2. So this would be absolute value of minus 3, minus 2. Absolute value, when you remove it, it becomes positive. So this will be 3, minus 2, this would be 1. Let me double check what it is going to be. It is absolute value of x minus 2 minus 3. So let me correct it. This will be minus 3. So this will be actually 0. So f minus 1 has a value of 0. So we have to find the value of g of f minus 1. Hence, it would be g of f minus 1. F minus 1 is 0. So g of 0. And the expression is x squared minus 4x plus 11. So 0, 0, it will be only 11. So it will be 0 squared minus 4, 0 plus 11 equals to 11. So g of f minus 1 is g of 0, which is 11.